My friends, look at the level of contradiction hidden in the underside of the most expensive and sophisticated aircraft ever developed by contemporary military engineering. The Lockheed Martin F-35 Lightning II was designed to operate as an invisible supercomputer in the skies, crossing enemy airspace. Armored with composite materials and perfectly sculpted shapes to scatter the waves of next-generation radars. But if you look closely at the fuselage of the F-35B and F-35C variants, there's a bump the size of a bathtub bolted directly to the belly of the fighter, at $110 million per unit. This external pod breaks the smooth lines of the stealth design, increases the radar cross-section, and adds severe aerodynamic drag that directly harms the platform's agility. At first glance, any casual observer would say that the Pentagon engineers made a catastrophic design mistake, destroying the main stealth advantage just to carry a heavy ballistic cannon. No one is talking about this, but my friends, what seems to be a gross design flaw is actually the most brilliant tactical solution to protect the integrity of the aircraft against its own firepower. Yes, my friends, we are entering the realm that defense analysts call the sacrificial capsule. It's when the theoretically perfect version of the fighter tries to hide its weapon internally and ends up destroying its own structural skin. With the mechanical stress, the models operated by the Navy and the Marines use this external pod to isolate stressors. 3,500 newtons of recoil force, ensuring that the fighter survives the brutality of its own shots. And to understand why the American military accepted degrading the aesthetics and transonic acceleration of their main aircraft? In exchange for this pod, we need to reopen the archive of trauma that changed the rules of war in the skies over Asia. Pay attention to the hidden history that dictates the Pentagon's design guidelines to this day, because the engineering decisions of the F-35 were written with the blood of the pilots who flew in Vietnam in the mid-1960s. But first, subscribe to the channel, turn on the notification bell, and leave a like on the video. It takes a lot of work to make this, my friends. At that time, the McDonnell Douglas F-4 Phantom II was the absolute ruler of the skies. A massive machine capable of carrying up to 8,500 kilos of weaponry distributed across 9 external hardpoints. The engineers of that time were so dazzled by the emergence of radar and heat-guided missiles that they made a radical decision. They completely removed the aircraft's internal cannon. The desk-bound theory claimed that close combat was dead and that missiles would eliminate any target before the enemy could even get close. But pay attention, because in the real world of mud and fire, the theory completely fell apart. The heat-seeking missile, the M9B Sidewinder, had a maximum effective range of 5, and it required the pilot to be positioned exactly behind the enemy's hot exhaust. And to make matters worse, the sensor's angular tracking head operated at only 11 degrees per second. A pathetic tracking rate that turned the missile into a useless death sentence if the enemy fighter performed any simple evasive maneuver. The radar-guided missile, the M70 Sparrow, was even worse, operating with a minimum engagement distance between 900 and 1,500 meters, requiring the pilot to keep the nose of the aircraft locked, pointed at the target during the entire trajectory of the projectile in hostile and saturated airspace. Flying in a straight line, waiting for impact, was an invitation to suicide, and that's what made the actual kill probability of the Sparrow drop to less than 10%. The rules of engagement forced American pilots to make visual identification before firing, destroying the long-range advantage and dragging the F-4 Phantom into high-speed, close-range dogfights, with no ballistic ammunition to defend themselves. The desperation of men like Navy pilot John Chezier, when they realized they didn't have a cannon to pierce the flanks of enemy fighters, forced a complete overhaul in the industry. The Phantom had to be hastily redesigned to receive the internal M61 Vulcan cannon, and engineers swore never to design a fighter without a gun barrel again. That's why when the requirements for the Joint Strike Fighter program were set in the early 2000s, installing a cannon was a non-negotiable mandate, requiring the ability to destroy light armored vehicles at a distance of up to 2,700 meters. The weapon chosen for the mission was the JAW-22A, a 4-barrel rotary Gatling-type cannon with a 25mm caliber developed by General Dynamics. We're talking about a beast weighing 104 kilograms of pure metal. It spits out 3,300 rounds per minute, which is equivalent to 55 high-impact projectiles flying through the air every second. The ammunition used is SFAT, a semi-armor piercing projectile with an explosive and incendiary warhead designed to tear through steel plates and detonate inside the target, setting enemy systems on fire from the inside out. The projectile leaves the barrel at a frightening speed of 0.85 kilometers per second, exceeding 3 times the speed of sound. But then we have the tension factor that dominates the cockpit, since the fighter carries a total inventory of only 220 rounds in its own magazines. The system's electronic controller severely limits the duration of each burst to blocks of 35 shots to prevent the barrels from overheating. And the result is that the pilot only has 5 or 6 chances to pull the trigger before completely emptying the ammunition stock. Each shot needs to be surgical and crucial.
Chances de puxar o gatilho antes de esvaziar completamente o estoque de munição. Cada disparo precisa ser cirúrgico.
The F-35 solves this precision by integrating target mapping into the helmet display and active electronically scanned array radars, ensuring that the line of fire follows the pilot's eye movement. The central problem that divided the engineering team was deciding where to install this mechanical monster inside the fuselage, without breaking the balance of the 3 variants of the project. But then comes the question: why is the F-35A, the main version, cracking in half? Because in this variant, operated by the United States Air Force, the designers followed the traditional path and accommodated the JAU-22A cannon. Internally, hidden in the left shoulder of the fuselage, behind a retractable door that opens only for a millisecond when firing, to preserve aerodynamics. On paper, it seemed like the perfect solution. In the reality of physical forces, this choice triggered chronic structural wear. Pay attention to the mechanics of the damage. When the JAU-22A opens fire, its 4 rotating barrels generate a brutal recoil force of 16,500 newtons. That's a heck of a lot of force. That's equivalent to the thrust of a small jet engine pushing the aircraft backward in the opposite direction of flight. On the F-22 Raptor, this impact is neutralized because the cannon was positioned at the wing root, where the massive spars absorb the energy. On the F-35A, however, the gun was mounted directly under the longitudinal beam that runs along the sharp edges of the fuselage. Every time the pilot pulls the trigger, the 16,500 newtons of impact go through this beam and dissipate directly into the composite skin of the fighter. This outer coating was not designed to withstand repeated high-frequency mechanical shock waves. And the result is that the outer skin starts to crack and the stealth coating splits and the plane's radar signature is damaged. Annual assessment reports issued by the Pentagon between 2016 and 2019 and 2023. They rated the internal cannon of the F-35A as inaccurate and having failed operational tests, due to severe vibrations that misaligned the sight and accelerated the fatigue of composite materials. The usage restrictions were severe to avoid catastrophic damage to the protective structure of the Air Force fighter. But in the other 2 variants, the F-35B of the Marines and the F-35C of the Navy, the chronic lack of internal space prevented the engineers from making the same mounting mistake. The F-35B needed to accommodate a huge vertical lift fan in the center of its body for short takeoffs, while the F-35C needs space to carry more than 1,000 kilograms of internal fuel to ensure range on ocean missions. With no free space left inside the chassis, the only solution was to outsource the problem for the 35B. It wasn't fuel assessments. The F 35B used fuel assessments, 35B assessments. The F.
É aqui que nasce o trunfo da cápsula de sacrifício. Esse pod de fibra de carbono pesado.
The F with its fuselage could reach a range fuselage million 35B F-35B million of heavy carbon completely isolates it to miles. Fuselage of the F-35B. The pod is attached to the station on the Senate line. From the belly of the plane, a robust mounting point located directly under the most stable and massive structural beam of the entire backbone of the aircraft. In practice, what happens when the cannon fires is that all the recoil energy is absorbed by the rigid structure of the pod and transferred directly to the central main beam, without a single vibration reaching the sensitive skin or the internal electronic components of the fighter, which is a supercomputer. But guys, yes, installing this pod does take a heavy toll on transonic speed performance, my friends. Industrial data reveals that while the F-35A needs 8 additional seconds to break the sound barrier and accelerate from Mach 0.8 to Mach 1.2 with its internal cannon, the F-35B takes 16 seconds longer due to the drag from the pod, and the Navy's F-35C requires an impressive 40 seconds. 40 extra seconds to overcome air resistance. 40 seconds is all you need to escape an enemy missile. It's a mathematical sacrifice of speed and transonic acceleration. But in exchange for those 40 seconds lost, the Navy ensured a platform whose structure remains intact after thousands of shots, free of cracks and with much higher ballistic accuracy, because the weapon doesn't suffer from the microstructural displacement of welding. What a mess, Shimon, but don't worry, I'll explain. This structural stability unlocked a new geopolitical capability that's reshaping the projection of naval forces in the Western Pacific through the concept known as the Lightning Carrier. Straight-deck amphibious assault ships like the USS Tripoli that you're seeing on the screen are actually being converted into light aircraft carriers by embarking up to 20 F-35B fighters, equipped with these high-impact pods. These vessels operate as a rapid response force, capable of launching entire squadrons in a matter of seconds, to provide high-precision radar-guided fire support for the ground marines without relying on the presence of complex electronic warfare aircraft or massive land runways. Look at the scale of this change. But the greatest strategic asset of Terra O's engineering is that the sacrificial capsule doesn't have to carry a cannon forever. The Danish engineers, who are geniuses, developed the multi-mission pod, a modular variant that uses exactly the same external carbon fiber mold, maintaining the same aerodynamic profile and the same level of drag already calculated by the onboard computer. And the result is that the space previously occupied by the cannon can be emptied to receive advanced electronic warfare systems, turning Casio into a jammer capable of deafening enemy radars. The pod can be reconfigured in minutes to carry long-range intelligence and reconnaissance sensors, directional data links to coordinate swarms of autonomous drones at the forefront, or even house compact direct energy laser systems to burn out the circuits of anti-aircraft missiles before they get close to the fleet. Laser weapons? The death ray on the F-35. My friends, this changes everything. Meanwhile, the F-35A is doomed to carry the dead weight of its internal cannon and its cracked fuselage for its entire service life. The B and C models gained unlimited modular flexibility, simply because the engineers were forced to put the gun on the outside. The laws of aerospace physics have shown that the blind pursuit of perfect aesthetics and absolute symmetry from engineering manuals almost destroyed the integrity of the most expensive fighter jet on the planet on the Air Force runways. The real engineering of naval forces has proven that the hostile environment of the combat front, the survival of materials, and tactical modularity outweigh any theoretical estimate of spec sheet performance. We saw the historical trauma of Vietnam demanding the presence of ballistic weapons. We saw the destructive recoil cracking the longitudinal beam of the F-35A. And we saw the pod of the Terma isolating the impacts to turn aerodynamic drag into multi-mission flexibility on the decks of the Lightning carriers. The tactical verdict under this force architecture is open for your in-depth analysis down here in the comments. On the other hand, accepting a bulge that degrades transonic acceleration and increases radar signature can be interpreted as a gross industrial planning failure. And it was. I respond, a state of technical desperation in the face of lack of internal space. On the other hand, isolating 16,500 newtons of recoil and creating a modular cradle for jammers and lasers revealed the brilliant strategy of long-term survival and adaptation. Now write the keyword here in the comments, strategy or desperation. I will read each technical statement to identify who understands the physics of force and who still judges defensive power by superficial couch appearances. The international scene has crossed the point of no return behind the scenes of industrial power, and the old media keeps delivering only the shell of highly simplified reports. For those seeking to understand the raw reality of defense technology and gain access to the raw dossiers before global supply chains suffer the next choke point, the open platforms monitored by the system are no longer safe. That's why we maintain our intelligence bunker. This is not a commercial entertainment channel, but a security and digital analysis solution where more than 3,000 elite analysts dissect military data in real time without the filters of institutional censorship. Access is available on your screen now through the QR code that's appearing in the link in the description and in the first pinned comment. Secure your place in this strategic community before the door closes. And we created our own channel for shows and movies. Yes, my friends, no more spending an hour scrolling through Netflix, Amazon, HBO, or whatever your platform is, trying to find the perfect movie so you don't waste 2 hours of your life. We did that for you. So on our series and movies channel with no woke culture, no whining, we recommend good content for you to enjoy with your family. Link in the description, in the first pinned comment, and also in the card that appears here in your video. Now it's time for the most important part. Subscribe to the channel, turn on the notification bell, leave a like on the video, shield and protect your mind. I'm Shimon Oliveira and I'll see you in the next video. See you then.